Okay, let's try this one. For example, we have, where's my next one? For example, I want to do the Laplace transform of 1 minus cosine of 2t over t. Laplace transform of 1 minus cosine of 2t over t. Laplace transform of 1 minus cosine of 2t over t. So go back to the cheat sheet. We're going to go back a couple slides. I wish I still had this on the board, but I don't. And decide which of our helpful tips is going to help us out in this case. Which helpful tip do we want to deal with? We've got 4 of them. 2 in the first category, 2 in the second category. I am going to want to be able to see all of you, and then I'm going to have you hold up fingers for me. So which helpful tip am I looking for? 1, 2, 3, or 4? There's 2 in the first category and 2 in the second category. Give me fingers. 1, 2, 3, or 4. Which helpful tip am I looking for? If I am, we'll go back to my example, looking at the Laplace transform of 1 minus cosine of 2t over t. Laplace transform of 1 minus cosine of 2t over t. Which helpful tip do I want? 1, 2, 3, or 4? Give me fingers, please. I am seeing 2s. Yes, good. Okay, let me minimize you so I can see my whiteboard again. And that means we need to evaluate an integral. So the question is, what do I have to evaluate the integral of? So we need to evaluate an integral. And I need the integral of the Laplace transform of 1 minus cosine of 2t, the part without the t that I am dividing by. That's what I'm looking to evaluate an integral of. Integral of the Laplace transform of 1 minus cosine of 2t. So let's figure out what that Laplace transform is. This is 2 parts, front of your book. Figure out what that one is. What is the integral that we're supposed to be evaluating in this case? Go ahead and check the front of your book. What's the Laplace transform of 1 minus cosine of 2t? Front of your book. One over s minus s over s squared plus 4. 1 over s minus s over s squared plus 4. Doing good. Okay, so now I need an integral. I'm going to put the limit as b goes to infinity out in front right away. We've been doing this for a while. So we need the limit as b goes to infinity, integral from s to b. And now I got to switch to sigmas. So 1 over sigma minus sigma over sigma squared plus 4 d sigma. If nothing else, I'm teaching you how to write Greek letters here. So integral from s to b as b goes to infinity, 1 over sigma minus sigma squared plus 4 over sigma. These are both going to be logs. I'm skipping the details of the u substitution. Write them out yourself by hand or look in my notes if you need to. We've got a limit as b goes to infinity, natural log of sigma minus 1/2 natural log of sigma squared plus 4 evaluated from s to b. Technically, I should have absolute values around the sigma and the sigma squared plus 4, but we're assuming that s is positive. So I can skip the absolute values on my antiderivatives in this case. Okay, plugging in. Limit as b goes to infinity, natural log of b minus 1/2 natural log of b squared plus 4. And then we've got minus the quantity, natural log of s minus 1/2 natural log of s squared plus 4. So we're plugging in b, plugging in s, and subtracting. Natural log of b minus 1/2 natural log of b squared plus 4 minus the quantity, natural log of s minus 1/2 natural log of s squared plus 4. All right, as b goes to infinity, I've got 2 pieces going to infinity here. This first piece goes to infinity, and this second piece goes to infinity, right? Think about the graph of natural log. As your input goes to infinity, the whole thing goes to infinity, which means we have infinity minus infinity, which is an indeterminate form. Sadly, it is not an indeterminate form that you can use L'Hopital's rule on right away. And I can only see 3 of you right now, but I bet the rest of you are looking equally as crabby. So here's the trick. Remember when we have a constant out in front, we can bring it up and make it an exponent. So this is really like the natural log of b squared plus 4 to the 1/2, right? When you have natural logs, the coefficients can come out in front. And then basically these natural logs are the same. So I've got a natural log of a b here. I've basically got a natural log of a b here also. It's a b squared, and then I'm taking the square root. So this is very imprecise, and Dr. Brown would get crabby with me, rightfully so. And if we were doing this actually in class and not virtually, I would make you put it together and use L'Hopital's rule. But basically, these are the same sizes of infinity, so basically they subtract to be 0. We're gonna go with that. If I had you in class, I would do it for real. But we're gonna say, close to the same size of infinity, they're gonna subtract and go to 0. And so therefore, my answer, if I distribute my negative through, is going to be negative natural log of s plus 1/2 natural log of, we'll throw that in parentheses, s squared plus 4. So if I distribute my negative through, the first part ends up being 0. And that is my answer. So going back up to the top, negative natural log of s plus 1/2 natural log of s squared plus 4. That's my transform in this case. So again, we were saying we are doing a forward transform, and I am dividing by t. So therefore I need to evaluate an integral. Think cheat sheet. We're doing a forward transform and we're dividing by t, so therefore we need to do an integral. All right, stop sharing. Questions? Anything for questions on that one? Anybody, anything? I can see all of you right now, so you can actually raise your hand if you want. I see none. Give me a thumbs up. This is, nope, Daniel has a question. Yes, sir.
What's a derivative?
Sorry?
What's a derivative?
Any other questions that deal with differential equations? Anybody, anything? I love you guys all very much. Thumbs up, we're good on that example. Yes, cheat sheet helps, thumbs up. Okay, we got one more here, last example, and then we will finish up for the day. Last one. How about this? Let me find the one that I haven't done yet. Here we go. For example, inverse Laplace transform of natural log of the quantity s squared plus 1 over s squared plus 4. Inverse Laplace transform of the quantity natural log of s squared plus 1 over s squared plus 4. Inverse Laplace transform of the quantity natural log of s squared plus 1 over s squared plus 4. Okay, I'm gonna pop back to my cheat sheet. I'm gonna let you look at that for just a minute, helpful tips. And then I'm going to put you all back together so that we can do fingers 1, 2, 3, or 4. So decide which we think we are dealing with, 1, 2, 3, or 4. Which of the helpful tips do we want to try to use for this one? 1, 2, 3, or 4. I'm going to stop sharing my screen and have you guys give me fingers. Helpful tips, 1, 2, 3, or 4. What do you got? Hold up fingers for me. Helpful tips. If you hold up 1 or 2, that's wrong. I am seeing 3s. 3s, mostly 3s, maybe. All right, let's go back to the whiteboard. 3 is, we are saying the inverse transform of the derivative is easier. Okay, let's take the derivative and see if that inverse transform is going to be any easier. So we are doing an inverse transform. So we're hoping that the inverse transform of the derivative is easier. So we could take the derivative, and this is going to be a disaster and a half, right? We're going to need to use quotient rule inside of chain rule, and I absolutely positively don't want to do that. So let's do it this way instead. I need a derivative, and I need a derivative of natural log of s squared plus 1 over s squared plus 4. That is the derivative that I am looking to find in this case. Properties of logs, before we do the derivative, so properties of logs first. When you are dividing, you are allowed to pull apart and add, subtract, multiply, or divide. Abby's saying subtract. Yes. When you are doing a natural log and you are dividing, you are allowed to pull apart and subtract. So this is the derivative. I haven't done that yet. Natural log of s squared plus 1 minus natural log of s squared plus 4. So I can pull apart and subtract if I am dividing. And then remember your derivative rules for natural log, please. So go ahead and take the derivative of each of those pieces separately. Go ahead and do that for me, please. Take the derivative of each of those pieces separately. Think about how this works with chain rule. Okay, so we've got 2s over s squared plus 1 minus 2s over s squared plus 4. We are really hoping that the inverse transform of that is easier. So what's the inverse transform of that derivative that we just found? Inverse transform of 2s plus 1 minus, or sorry, inverse transform of 2s over s squared plus 1 minus 2s over s squared plus 4. Front of the book. Look in the front of your book. These should both be there. You should be able to find both of these. Two cosine t minus 2 cosine 2t. 2 cosine t minus 2 cosine 2t. All right, so then popping back to our list of helpful tips, we said the inverse transform of the derivative is easier. So what we have to do is multiply by -1 and divide by t. Multiply by -1 and divide by t. So therefore, my answer is going to be what I just had once I multiply by -1 and divide by t. So final answer, we'll do it as -1 over t out in front, 2 cosine t minus 2 cosine 2t. Multiply by -1 and divide by t. And there's my inverse transform. You could put that over a common denominator if you wanted, and you could flip the order in the numerator if you wanted to multiply the -1 through. So if you wanted to, you could do a little bit more simplifying, or you can just leave it like this. Okay, questions, anything, virtual hand raise before I stop sharing my screen, because I want to come back together, but anything, if you got, while you still want to see something on the screen, do a virtual hand raise before I stop sharing my whiteboard here. I'm thinking we're good. Okay, so here's today's summary. This is what you want to remember. 4 helpful tips, and divide them into those 2 categories. Am I taking an inverse transform? Or we'll do regular first. Am I taking a regular transform, or am I taking an inverse transform? That's the first question you want to ask. And then divide each of those into categories. If I'm taking a regular transform, am I multiplying or dividing by t? That tells me whether I need to take a derivative or an integral. If I'm taking an inverse transform, is the derivative or is the integral easier to work with? So those are your helpful tips. I've never done this with helpful tips before. I've just kind of written out all of the steps and equations and then tried to go from there. Do the helpful tips help? Are they helpful? Yes, maybe, yes, okay, we think so. We'll see what happens when you're doing your homework, but hopefully those help, having it all in one place. I was looking over notes for class today and I'm like, I am never going to be able to keep this straight and look at a computer screen and switch back and forth between the whiteboards. So I'm writing out helpful tips for myself and hopefully they'll help you out also. Stuart, question.
Do you have any helpful tips for writing Greek letters?
Nope, got nothing. Learn
They
how
all
to
look
do
like
it.
numbers.
Yes, you need practice. If I can write Greek letters on a virtual whiteboard, you can learn how to do it for real with a real pencil and a real piece of paper. There's my challenge for you. Okay, anything else for questions on this section? All right, make sure to get your homework submitted by 2 o'clock this afternoon. Touch base with your group members if you need to and finish up your homework submissions then. I don't know that I'll get them back to you tomorrow, but hopefully by Wednesday. I've gotten better at grading these on the screen, so I don't think I have to print them out. And I'm not promising tomorrow, but hopefully by Wednesday. Check out the schedule on Moodle. I will correct those dates for the sections, but that'll tell you what's coming up for the rest of the semester. I'm having a hard time organizing everything, and I am the most hyper-organized person in the world. So if I'm having a hard time organizing everything, I can only imagine what you guys are dealing with. I wanted to make it as easy as I possibly could, so that sheet is up on Moodle there. If you notice anything else wrong, or if you have questions, let me know. Anything else? Last call before we sign off today. All right, awesome. Don't forget I have virtual office hours tomorrow afternoon. I do have some meetings scheduled to go over class schedules. So if you want to pop into my virtual office hours tomorrow afternoon, maybe just shoot me an email and let me know so I can expect you. But if you forget and have questions, feel free to come on in anyway. Otherwise, I will see you for class tomorrow. Have a good day. Bye, guys.